Hello and welcome to another C++ tutorial. So this time we are going to be taking a look at the area known as casting, which is a process of converting something from one type to another. And generally it's not actually changing the underlying data, it's just giving us a different perspective on it. That could be through a different type, that could be through changing sort of some of the properties of how it's being viewed, whether it's constant or non-constant. So it gives us a way of doing things like this, and it's incredibly handy, incredibly powerful tool, and C++ gives us a lot of options for that. So we're going to take a look at some of the key bits, and we're going to get that up and running. Okay, so in order to test the different cast switch, the way we're going to do this is rather than just going direct and saying, okay, here's this cast, use it in this scenario, we're going to test out a few different scenarios. So we're going to get an understanding of how the different casts work through essentially experimentation. And this is something that I do really encourage with learning aspects of coding is don't be afraid to experiment, and trying to build that understanding from experimenting can be really good at helping sort of cement an understanding of what's actually happening. So I'm going to set up just a simple parent class here. I'm going to give it a public integer that I will just call value, and I'm going to give it a function just called test, like that. And then I want to set up down here a child class, and we'll have child class A, and that's going to inherit from parent class. We'll just have it be an empty body there for it. I then want to have child class B. It's going to be exactly the same thing. So essentially we have two classes that are different types, but they share a parent, so they're sibling classes. So I want to very intentionally do that. And so what I'm going to do to start off with is I'm going to set up a couple of bits of data. So we're going to have a score, which I'll make 42. I'm going to have a max score, which is 100. And then we're going to see, firstly, a very common cast that we would often do. So one thing I'm going to do is I'm going to do percentage here. And I'm going to say that that is score divided by max score. And then I'm just going to output that percentage. I'll also put this in its own little block just so we can easily sort of separate it out. So I just want to output this. So percentage is like that. So let's run this. Let's see what we get. And can see I get 0 output. And we do have a bit of an indication as to what's going on, that we're getting a conversion from integer to float and that happening here. And this is such an easy problem to run into. And because this, although this is going into a float, this side is evaluated independently. And it sees integer divided by integer, so it keeps it as that. So one thing I can do for a very simple cast is I can just do float like that. And I don't need to do it to all of the things. I just need to do it to one of them. So that's one very simple way of doing the cast. The other way that I could do this, and I'll do this on I'll call this percentage 1, and we'll have a percentage 2 as well. So the other way that I could do this is like this. And this is where we use one of those casts. So I do a static cast to a float of one of the parameters. And if I run that, we'll see that that works fine. So this type of cast here is known as a C-style cast. And we will look at that more later towards the end. I want to, for now, focus on this static cast, because it's a really important one. And, okay, we can see, yep, in this scenario here, works quite straightforward. But, okay, what makes static cast useful or interesting? Well, let's try to do something that doesn't make sense. So let's have test value, and we'll do a static cast to, obviously, a standard string. And we'll do that of, let's say, 42. So we do that, and it immediately is actually giving us compile errors. And if we try and compile it, it won't. So static cast checks if a cast is valid, if it is reasonable at compile time. So in this case, this isn't valid, so it can't do that. Now if I set up some of our classes here, so let's have a parent class, and we'll call this test class 1 is a new, and we'll make that child class A. We'll do a similar thing for, rather than being 1, it will be 2, and we'll go for that being child class B. And then just for final measure, I have child class A, test class 3. That can be a new one of A. And then down here, I'm just going to make sure I'm deleting all of those, just because this is a good habit to get into to make sure you're cleaning up memory that you don't need. So we can do that. So, okay, let's test using static cast with these. So I'm going to have, and this is where I'll use auto just to save some writing out. So I'll have test var 1, and we'll do a static cast to child class A of test class 1, which that should be a valid conversion. Actually, we need to put pointer. That should be a valid conversion. Well, let's also try converting one that we know should be invalid. And we'll do a static cast again to child class A, but this one will be of class 2. And then finally, we'll do one where what we do is we convert to our parent class pointer, and we'll convert test class 3. So this one is a valid conversion. This one is a valid conversion. This one is actually not a valid conversion. But let's see if it runs and we at least get output from it. So we're going to output test var 1, test var 2, and test var 3. Now I'm not doing anything special here in terms of trying to format things or run functions on them. I just want to see, is it giving me something where I'm actually getting the conversion is running and I'm getting something output that seems reasonable. So this is static cast let's see what happens. So runs, we can see that in each case we've gotten conversions have happened. So that's correct that it has actually converted all of those. And so it's got what it considers to be valid pointers there. But we have converted here something to a type that is not valid. Now, depending upon how things go, that could cause errors because we do have this as a completely incorrect type. And if I just in case your auto is somehow doing something magical, it really shouldn't be. But if we just want to really prove to ourselves that it has gone and put it into the wrong pointer type, then we can see we get the same results. So it's not auto, correcting things behind the scenes. And this is code that could actually run probably in a lot of cases without issues. But it is something that as we have more complex classes, this will inevitably cause a problem. So static cast can pick up on things at compile time, but only within reason. There are some things that it cannot pick up on. And this is a scenario where that's the case. Static cast, when we're working with inheritance, polymorphism sort of areas, static cast is generally not what we want to actually use because it does not do an appropriate set of tests. This is where we are now going to look at one called dynamic cast. So we'll skip the percentage stuff because dynamic cast is primarily used when we are working with inheritance. That is actually the big use case for it. So when we're dealing with inheritance and polymorphism, dynamic cast is what we should be using. Now, you will notice that it's giving errors here. This one works, so casting to the parent works, but casting to these children, this is a likely error that you may get if you're testing this with a very, very simple class, where it's saying it's not a polymorphic type. That is because, technically, these are not polymorphic yet. To make it do that, we have to make this function virtual. Now we have polymorphism taking place. You just need to have at least one virtual function, then it's going to have it be taking place. So let's see what happens with this now, because we have valid conversion, an invalid conversion, and then a valid one. And static cast didn't care, but does dynamic cast care? So we run it, and we will notice this middle one that's invalid, it's come back as null. So dynamic cast is going to do runtime checks. So static cast is great for things where you can validly test that setup at compile time, but dynamic cast, anytime you are doing stuff where you're working with inheritance, polymorphism side of things, always be using dynamic cast, because if the conversion is invalid, it will come through as all zeros, which translates to, effectively, it is coming through as a null pointer, which is perfect. That means we can do a dynamic cast from one type to another, and if what we get back is null, that means it's not that type. So dynamic cast is a way that you can actually test the type of something, which is super, super handy if you need to do specific behavior for that. So highly, highly recommend not just recommend, I would say you absolutely must be using dynamic cast if you're doing setup where you've got inheritance and polymorphism. Okay, so that's static and dynamic cast. Now we get to some of the really fun ones that let us start to do things that, again, the standard thing that I often say with C++, it gives you lots and lots of tools to build platforms and to build railings to keep things safe but it leaves it kind of up to you whether you do that. And for everything that it gives you to build safety, it also gives you a way to kind of work around that if you need to. So constcast is a really great example of that. So what I'm going to do is I'm going to copy this block, and what we'll set up is, okay, I'm going to create parent class here, test var1. I'm going to set value, and we'll get rid of these for now. Let's incorrectly guess the right type there. So we'll set the value to 42. And then I'm going to create a const reference to it. So test var2. So we've created a const reference to that. So while I can do this, I would not be able to go test var2 value is equal to 500 because it's const. Const means we can't change it. But this is where constcast comes in. There are sometimes cases, in particular if you've got large code bases, you might have a library that has very rigorously enforced const correctness, or you might have a library that really goes the opposite way, and you might need to have these different things be working together. And so sometimes you just kind of have to undo the const on something. And constcast is something that if you find you are writing it, it is another one of those ones where it should be absolutely a moment of pause and you check and see, is there an architectural issue here that should be fixed? Constcast in particular, if you're having to use it a lot, is likely a sign that there is a larger change that needs to happen to fix and improve things. But how we can use this is we can go constcast parent class test var2 like that, dot value is equal to 500. And in this case, we would do constcast like that. And we can test this because we will see that it has actually changed. We don't really need to output the value for test var2, but we will just for completeness. And I will comment out this line. And if we run it, we'll see it's managed to work. It has actually changed it. So constcast, really handy if we need to remove const from something. Again, want to be very cautious about when and where we do that because it is not something that is generally a good idea to be doing. Now we get down to, we're starting to get to the ones that allow us to do even more ridiculous stuff. So we get to reinterpret cast. Oops, oops, if I can spell it. I'm going to just write it down here. And that's going to make my life a little bit easier because sometimes it is less than simple to spell stuff. So let's see what happens just with our previous example with reinterpret cast. See if we can get a bit of a sense of what it's actually doing. So we can see it gets the same results as the static cast. So that's one thing we know about reinterpret cast. It's not doing those polymorphic checks to see if it's valid. But let's see how ridiculous this gets. Let's go test var4, and I'm going to do a reinterpret cast to, let's go parent class of, And we had a max score up here. So let's do a reinterpret of max score. And let's see if we can output that. So this is going from something that is completely invalid to something else. We could actually go even more ridiculous. String test would actually go for from that. Let's go for something. If we're going to go ridiculous, we might as well go really ridiculous. So let's test that. And I didn't add in the nice spacing, so I'll add in the spacing. But it did actually do that conversion. This is what I mean with the taking off of safety rails. So reinterpret cast will end up converting from anything to anything, which means I could get here and go, cool, well, test var 4, let's run your test function. And remember, test var 4 is pointing to a string, but I have told it that no, that location in memory, treat that as this parent class. And running that function, you can see it's kind of stalled out. And if I actually run it directly with it attached, we can see we do get an exception. And in particular, the exception that we're getting here is that an access violation, because we're trying to do stuff that is absolutely invalid. So we want to be very careful with reinterpret cast. However, it does have its uses. So reinterpret cast, you will often see that with stuff that is doing serialization of things, so saving and loading or communications over network, because you're taking stuff from a buffer that is just bytes, and then you need to convert that into other data types. So reinterpret cast, you'll very commonly see it in serialization, and it's actually a very appropriate use of it, and probably the main use we tend to see for it. But again, if you find you're writing reinterpret cast and you're in an area that isn't doing something where it's serializing to and from byte arrays or similar, you probably want to have, again, that moment of pause and think, okay, is this really the right thing I should be doing? And speaking of asking that question of, is it really the right thing I should be doing? Finally, we're going to look at the C style cast. Which, what that looks like is this. So that same thing we used further up with the float is a C style cast. So what does this do? Exact same results as the reinterpret cast. So a C style cast is something that, again, we generally, the only time where I would be recommending using it is scenarios like this. Because static cast, we can use it for that, but it's a bit verbose. So using it for converting, I would only generally ever use it where I'm converting between numerical types. So things where I might want to convert an enum or something to an enum, floats to integers, stuff like that. Those are cases where I would be, or integers to floats. Those are cases where I'd be using a C-style cast. I would never use something like a C-style cast if I am working with polymorphism. I would never do that, and I would strongly recommend against ever doing that because you have no safety rails. As we saw, we can convert a string to something that is completely invalid. Same as with reinterpret cast. So these ones are ones that we really only want to be using them in very specific cases. So just a sort of recap of where we should be using different ones. C-style cast, anytime we're doing sort of a conversion with a numerical type, is something where I would recommend using a C-style cast. Static cast is something where I find I tend to not use it a heap because it doesn't have a lot of the type checking that I want. I generally would be using C-style casts for simple cases. For anything with polymorphism, I would always use a dynamic cast. That's just best practice. For something where I'm converting between things like tool from a memory buffer, reinterpret cast would be absolutely the go-to. I could, technically use a C-style cast there, but I think it's good to have that signaling of here's something that I'm specifically writing that I know it's not unsafe, but it has no safety checks. So I do believe in using that rather than a C-style cast, even though we could use that. And const cast, if you're interfacing with const correct code and you're having to undo that, but again, if you find you're writing const cast a lot, then check and take a pause to see if there are maybe architectural issues that you're trying to work around, and there might be a better way of solving it. I wouldn't be using const cast a lot. It's usually a sign of it'll often feel like you're sort of fighting against the code, and when you notice that, that is usually an architectural issue. So take a step back and reassess it. That's the basics of doing casting in C++. Dive on in and experiment with this. As I said, we got an understanding of how these are working through experimentation, and I think that's a very important part of building up understanding with code, is writing stuff and seeing what happens, seeing what breaks, what things don't. Sometimes the breakages can be very subtle and you won't notice them till a lot later, and that's why I've pointed out some of the things with like where you should use the particular casts. But in general, it's a really great way of getting an understanding of how things work. And when you run into those problems, it can give you a deeper understanding of it. It means you're going to run into more problems doing that experimentation. You are guaranteed to be running into errors, but those are a learning opportunity. Those are a chance to get more of an understanding of how things are working. And I think that's a fundamentally essential and valuable thing for learning programming. So experiment. See what kind of mayhem you can create. Try out the different casts, try it out with different combinations, see what does and doesn't work. Thanks, folks. Hope you found the video interesting and helpful. If you have, chuck in a like and subscribe. It really helps out. It's really appreciated. If you're looking for the code for the project, that code is available up on GitHub, and there's a link to that in the description below. If you've got any questions, chuck those in a comment, or suggestions of things that you'd like to be seeing in other videos, then also mention those. And if you're looking for other ways to support the channel, then I do have a Patreon, and there's a link to that in the description as well. But until next time, bye.